So, in thinking about these proportional relationships and solving these mysteries or finding the missing values, you first want to determine your constant of proportionality, right? How it's growing, right? So, you can either multiply if you're given your information here to get here. So in this first example, we could think about, well, what did we do to this 3 to turn it into a 45? It's 3 is smaller than 45, so what did we multiply it by? And we know that 45 divided by 15 gets us 3, or 3 times 15 gets us 45. So in this case, we're multiplying by 15, right? So if we were thinking of it like a fraction, we essentially would be multiplying our diva would be a 15. In this case, we call it a constant of proportionality. So if in order to know over 3 weeks, your savings were $45, and we know that it's growing at a constant rate, or it's a proportional relationship here, we're going to do the same thing here. So since we're starting with weeks, we're going to end up multiplying it again. We're going to multiply it by our constant of proportionality. So 10 times 15 gets us $150. Woo, that looks like a crazy 150. All right. And then to work backwards, right? If we're given our savings, we can do the inverse operation. The opposite operation of multiplication is division. So since it's a constant rate, we're going to be dividing by the same thing, but we're just going to do the opposite operation. So 255 divided by 15 is what we're going to solve next. So it goes into 2 0 times, 15 goes into 25 one time, which is 15. When we subtract, we end up with 10. Well, 15 doesn't fit into 10, so we can bring it down now. And how many times does 15 fit into 105? And that is 7. And it fits exactly, so we have nothing left over. So after 17 weeks, you will have saved $255. So again, here on number 2, we can go ahead and start it together. So we know that it's a proportional relationship. So these are going to grow or change at a constant rate. So your input and your output, so to speak, are going to grow at a similar rate. Well, here's our given one. We have a 12 to 84 ratio. So what did we do to that 12 to turn it into an 84? Well, we can multiply it by 7. So if we know that we're going to be multiplying by 7 as our constant, right? If our constant, our k, our rate of change is 7, we're going to do that in all of these here. So go ahead and pause the video and see if you can solve this one on your own. All right, and let's see if ours match. So 9 times 7 got us 63, and 35 divided by 7 got us 5. So here in the solving problems section, you can see that we are still going to be solving a mystery, right? We're given some information but need to find other. So we have a cyclist. So a cyclist is riding his bike at 22 feet per second. Okay, so we have feet per second. I'm just doing the first letter for time. So feet to second. So we know that he's traveling 22 feet per second, per 1 second. So we have a 22 to 1 ratio. How far will the cyclist travel then in 15 seconds? Well, seconds is on this side of our ratio here, our rate. So this is then our mystery. Well, what did we do to this 1 to turn it into a 15? Well, we multiplied it essentially by 15. Legal to do so long as whatever you do to one side, you keep it proportional and do the same to the other. So you are going to then say, all right, well, let's take our 22 and multiply it by 15 to solve our mystery. And 22 times 15, you may use a calculator here since we're not explicitly practicing. Multiplication gets us 330 feet in 15. That's an F, feet, or FT for feet, in 15 seconds.